Okay, so this video is a short take on 3D printing. And so we're 3D printing massing objects out of FormIt. And this is, again, very much an introductory kind of thing. So first thing that we want to know about 3D printing is we have to make sure our models are watertight. Okay, so watertight refers to an object being fully enclosed. And if I am in FormIt, I can check water tightness by going to Visual Styles. If I don't have that open, it is right here, Window, Visual Styles. Make sure that that's checked. I can go to my wrench and identify watertight issues. This model is good to go, but let's break it. So if I select a face and delete it, this model is no longer watertight, which means the slicer, when we send this, just the stage just before sending this to a 3D printer, is going to have trouble identifying what is inside and what is outside. So in other words, what's a solid and what's a void. And it sounds simple on the onset, but it is actually a fairly complicated problem. So you can see if I come into the inside, and let's just go ahead and patch this in as well, right? So I'm going to make that a solid plane. And it's really only dividing these two objects. So just to prove that it's not the gaping hole on this end as well, let's go ahead and patch that in back. And I still have a watertight issue right here. Essentially, what's happening is I have coplanar geometry and a slicer. So a slicer is essentially our print driver for our university's case. It is the Prusa slicer, which is an excellent slicing software. It looks at a solid object and it's going to slice it approximately, well, whatever we say. In this case, the default is 0.2 millimeters. Every 0.2 millimeters vertically, it's going to create a slice so that an object can be 3D printed. And we'll talk about that just a bit more in a second. But if I have coplanar geometry, right, something in here, it's going to have trouble sometimes determining, is this a solid or is this a solid? Is this a void or is this a void? What is inside? What is outside? So watertight issues can be a little bit tricksy. So let's delete that. Let's delete my coplanar piece of geometry, and then let's put this back together, making sure that everything's ready to go with this checkbox, watertight issues. This is solid. It shouldn't have any problems 3D printing. It is ready to export out of FormIt and into our slicing software. So what I'm going to do, I'm going to select everything. So in FormIt, that's a double click. Everybody's selected. I'm going to go File, Export, and Locally. At this point, I'm going to use Selected Only. That's what we've had the best luck with out of FormIt. At times you have, like in this particular case, I have some terrain built inside of FormIt. And I would want to make sure, even though it's not visible, that it is not going to export. So I'm going to use, I'd say 90% of the time, I go to this selected only. My file format of choice for 3D printing is stereolithography, STL, and I'm going to hit export. So this is tiny house mass, and save. So next I'm going to go to my Prusa slicer. So we use the MK3, which is best 3D printers we've ever used by a lot. At our architecture program, absolutely love them, especially when you factor in cost. They're brilliant. Couldn't recommend them enough. So I'm going to go File, Import, STL. I'm going to navigate to my tiny house mass and say Open. Now, immediately we're going to run into a problem, and that is, if I look at my Y dimension, it is 60 millimeters. If I go back into FormIt and I measure, measure tool, there we go, measure, you'll see Y direction, 60 feet. And this is going to be a constant that we deal with from most architectural software into a slicer. Our base unit in terms of the Cartesian coordinate axis system is often 1 foot. Inside of something like slicing software, it is going to be 1 millimeter. So we already have a conversion factor going on with our scale. And for architecture, it's not good enough to just print this out. We need this at, say, 1 inch equals 40 feet for a massing model to include in a larger context model. Also, 3D printing is done with a series of layers. So we want to talk about things that 3D printers can do and things that they're going to struggle with. So we've got scale, and then we've got the actual printing process, what can be printed. Because even though it feels like it is actually not magic. There's still physics that happen. So what I'm going to do next is let's establish a scale. And because it's a bit complicated, we wrote a little Excel spreadsheet to help us out. So essentially what this spreadsheet does, and I'm happy to provide the formulas for anybody who might need them, just contact me via YouTube. This formula is 1 inch is equal to this cell right here, 16 feet. So this would be for a 16th inch scale model. In other words, 1 inch equals 16 feet. So I would come to this right here, scale factor for what we started with, Cura MakerBot from Revit or FormIt. We could also include in that list, in this case, Prusa. A scale factor, which takes into account changing from feet to millimeters, to get a 1/16 inch scale model would be 158.69%. So if I go into Prusa Slicer, and on my scale factor, I do 158.69, I have a 16th inch model. Now, this is a massing model, and this is a WYSIWYG. What you see is what you get, base plate from our 3D printer, and that's just a lot of plastic for not a lot of detail. So a 16th inch scale for this kind of thing is kind of ridiculous. So let's change that to a 40th. So 1 inch equals 40 feet. My cells I'll repopulate, and now my scale factor is 63.47. So let's change that down, 63.47. That is a much more reasonable object, slightly bigger than a Lego piece, a standard Lego piece. So I'm good with that. So the next thing I'm going to do is run the slice. So this is where it takes that object and divides it into layers, because 3D printing is essentially two-dimensional printing over and over and over again to build up an object. So this is layer 1, layer 2. Let's continue moving on up, and you can start to see both the infill and how everything is working. It's a little bit weird. Oh, I'm extending the base up. There we go. Layer 1, all the way up as this builds. So let's talk a little bit about the limitations. So obviously, if we think about stacking, which is what's happening in a 3D printer, an open angle like this, easy peasy. It's going to stack up just like stairs. The higher the resolution, the fewer the stair steps we see, and the more that will look like a smooth angle. 3D printing is also perfectly happy to stack going out, all the way up slightly past a 45-degree angle, because essentially it is stacking plastic on top of plastic as it works its way up. And to a certain extent, it will be happy to bridge, right? So I can bridge across this. What it won't do very well is a cantilever. If I had a roof overhang, there would be nothing to catch that edge of plastic. Doesn't like to do that very much. So setting up your 3D printing to be successful on the outset, super important. Next, in terms of printing time, see this is a lot of work for an hour, right? This is a 51-minute print. One of the things that's taking a lot of time is all of this infill to make this a solid object. And that is because my infill right now is set to 15%. I'm not going to put an elephant on top of this or anything. It's not even big enough to do that. I do not need all of that infill. I need a little bit just to keep the structure of the roof intact, but I don't need that. So let's drop that all the way down to 5%. Rerun the slice. And you can see now I cut about 10 minutes off. Well, to come to think of it, maybe I don't need any infill at all. 0%. Slice that again. And you can see I'm down now to 40 minutes. It's not worth it to not have any infill at all to me. So we've got about a 40-minute, 43-minute print for this. Totally acceptable, especially if I think, I might have 10 different options and I'm going to print 10 of them. It's certainly going to take more than 43 minutes, but it would take me a lot longer to build all those variations by hand. So this is a system that we really love as we're starting to build options, as we're starting to build urban models, things like that. From here, what we need to do next is export the G-code. So this is the set of tool instructions for the 3D printer. So I'm going to hit export G-code. It is going to say the file's name, the resolution that we're printing, which is 0.2 millimeters, the printer we're sending it to, I should say the material, PLA, the printer we're sending it to, MK3, and the time, all in one file. I'm going to hit save to that. And now it's down to our actual 3D printer. Typically with those, we're putting that G-code file onto an SD card, the SD card into the 3D printer, and we hit go. Simple as that.